This is one of those classic data science interview questions that seems simple, but it's actually a test of how well you understand machine learning data preparation. Here's the question. How do you convert categorical variables into numerical formats? The reason this matters is simple. Machine learning models can't understand text directly, they only process numbers. So when you have columns like region, segment, or satisfaction level, you need to translate those words into numeric values that your model can understand without changing their meaning. Now, there are several ways to do this, and choosing the right one can make a real difference to your model's performance. The first method is label encoding. It's the most straightforward approach. You simply assign a unique number to each category. For example, basic becomes 0, standard becomes 1, and premium becomes 2. It's quick and efficient, but there's one important catch. It creates an artificial sense of order between categories that might not actually be ordered. So label encoding should only be used when the categories have a natural ranking, like education levels or satisfaction scores. The second method is one-hot encoding. This one's a favorite for most machine learning workflows. Instead of assigning numbers, it creates a new binary column for each category. So if your region column has north, south, east, and west, you'll end up with 4 new columns, each marked with 1s and 0s depending on where each record belongs. This avoids any unwanted hierarchy between categories. It's ideal when the categories are independent, like city names, product types, or departments. Next is target encoding, which is often used when your dataset has too many unique categories, for example, hundreds of product IDs or user segments. Instead of creating hundreds of new columns, you replace each category with the average value of your target variable. So if premium customers usually have higher retention, that category would get a higher numeric value. It's compact and powerful. But remember, you must use it carefully during training to avoid leaking information from your test set. And finally, there's ordinal encoding. This one is designed for features with a clear order, like low, medium, and high. Here you assign increasing numbers to reflect the ranking. The model now knows that medium is between low and high. This works beautifully for anything with a built-in progression, such as satisfaction scores, survey ratings, or experience levels. Let's make this more concrete with a simple example. Imagine you're working with a small customer dataset. You've got a few columns: customer ID, segment type, region, and satisfaction level. For the region column, since there's no natural order, we use one-hot encoding. We can do that easily in Pandas using the getDummies function, which creates new binary columns for each region automatically. For the segment column, which has repeating text values like basic, standard, and premium, we can use label encoding. The label encoder from the scikit-learn preprocessing library assigns each unique value a number automatically. Then, for the satisfaction column, since it's clearly ordered, we can use ordinal encoding. We create a small mapping where low is 1, medium is 2, and high is 3. This keeps the sense of order while still converting everything into numeric form. Now, here's how you decide which method to use in real-world projects. Go with one-hot encoding when your data is nominal. That means categories that have no order, like cities, countries, or products. It's especially effective in tree-based models like random forests or gradient boosting. Use label or ordinal encoding when order matters or when you're working with memory constraints. For example, if you have a feature like risk level or customer rating, ordinal encoding preserves that natural ranking. Label encoding also works better when you have many unique values, since one-hot could blow up your dataset into hundreds of extra columns. Why does all this matter? Because encoding is one of the most underestimated steps in model development. If you choose the wrong method, your model might misinterpret relationships or assign false importance to features. But when you pick the right encoding, you're effectively teaching the model to understand your data's language accurately. So, if this question comes up in a data science interview, here's how you can answer it clearly and confidently. I use different encoding methods depending on the type of categorical data. For unordered categories, I use one-hot encoding. For ordered categories, I use label or ordinal encoding. And when I'm dealing with high-cardinality features, I use target encoding to simplify the data while preserving the relationship with the target. The goal is to maintain meaning without adding bias or unnecessary complexity. That's the kind of structured, confident answer that immediately tells an interviewer you understand both the what and the why behind one of the most important pre-processing steps in data science.